Welcome back. We have talked about discrete functions in the previous lesson. That's one type of relation and function. We're now going to talk about a different type of relation called a continuous relation. So after the lesson today, you should be able to determine if a relation is a function still, just like last lesson, only presented differently. And you should be able to understand what a continuous relationship is and find the domain and range of these continuous relationships. So what is a continuous relation? Continuous relation is a relation whose graph is made up of connected, let me get my pen working, of connected lines or curves without any breaks or gaps. So let's first look at these two graphs are the same right now. The first graph nothing is connected. There are breaks, there are gaps, they're distinct unconnected points. So this is a discrete, just like we talked about before. It's unconnected points. But what would happen if I decided to connect the lines? I'm going to make this even a little bit darker so we can see that those points kind of go away. So I've got now there are no breaks or gaps. Okay, I've covered up the individual points because when we have something continuous, we shouldn't have little individual points. It should be continuous. Now, I don't want you to connect lines in this lesson. I'm only showing you this as an example of something that is a continuous relation. It has no breaks or gaps. Okay, so let's really quickly review the domain and range of a relation. So again, and let's talk about the notation we use, because the notation we use for continuous is different. So in a discrete relation, we use something that was called set notation. Remembering that set notation looks like that curly bracket, and when we want to find the domain and range, we list all of the coordinate pairs and then find those x values. So the coordinate pairs here is 1, 3, 2, let me use a different color here. 1, 3, 2, 1, 3, negative 1, 4, 2, 5, 0, and 6, 6. So if I want to find the domain, list all those x values. So 1, 2, 3, 4, 5, 6. And end with a curly bracket, a set notation. And then the range is my y values. I'll use a different color here. And remembering that that domain is your x values. So my y values are my the range are my y values, which is -1. We list least to greatest, then 0, then 1, 2, 3, and 6. Now notice I put a parentheses here. That's a mistake. I should have put a curly bracket as set notation. So we will use parentheses, so that's probably why I did it. I was thinking ahead, but we need to use that set notation for discrete. Okay, and I'm going to underline discrete here. That's important. So that's a review from the previous lesson, set notation. So when we have a continuous relation, we use something called interval notation. Interval notation has brackets and it has parentheses. We use brackets when we want to include the end value, and we use parentheses when we don't want to include the end value, okay? Or specifically also, we use arrows, okay, like this or like this, to show infinity where the graph continues forever. Okay, so when you see arrows, we're going to think about infinity, okay, and we use parentheses to show that. So I'm going to highlight parentheses when we don't want to include, and we use brackets when we do want to include. So what does that look like in an example? So here's two continuous graphs. If I am trying to find the domain of this graph, remembering that domain is still my x values, and when I want to find the domain, I'm going to write it as a coordinate pair, sort of, and it's always going to be your farthest left to farthest right. Okay, so my farthest left, oh, that's really dark. Let's pick a different color. So my farthest left to my farthest right. I'm trying to find a lighter color here. Let's pick maybe this yellow color. Oh, okay, that's a little bit the same. Let's use, give me a second here. I want to make sure that I'm picking a color that makes sense here. Let's try this green. Oh yeah, that's good. Okay, so my farthest left to my farthest right. So when I write my domain, I'm going to make sure, and I'm going to write a little bit underneath it because I didn't leave a lot of room. So my domain is right here as my farthest left. And what is my x value there? My x value is 2. And I'm going to put that in a bracket because that point is specific. It's on the graph. It's not an arrow. It's not going on forever. And it's not an open circle. So I'm going to put a 2 there with a bracket. And then my farthest right are these 2 arrows right here. And like I said in the definition, we're going to write infinity because that's my farthest right, and we use a parentheses to connect it. So what this notation is saying is that this graph goes from the number 2 as my x value, and then it goes on forever right as my second x value. Okay, so that's my domain. My range then, I'm going to use green here to match the highlight. So my range are all my y values, listed the same way in like sort of a coordinate pair. And I'm going to look at my most bottom. Okay, my range is my farthest. My farthest bottom. We can actually say, let's say lowest bottom to the highest top. Sorry that I didn't leave you guys enough room here. I should have left more room for these examples. So my farthest bottom is the same as my furthest right, which is right here. And it has an arrow, so my most lowest point is going to be, and it's negative infinity because it's going on forever down. And when we have a grid, remembering that, and I'll draw a little picture here. Okay, when I go down forever, that's negative. When I go up forever, it's positive. When I go right forever, it's positive, and left forever is negative. So I would draw a little picture of that to show yourself where infinity would go. And in this case, since it's going down forever, that's negative infinity. And then the farthest top is another arrow. That arrow goes on for infinity up, so that's positive infinity. We don't put a negative in front. I know this is new. I know this is a lot of information. So again, if you want to pause the video here and come ask me for help, that is totally okay. And sometimes that's necessary, right? Especially for a new concept like this. Okay, let's take a look at the second example. It's the same concept of farthest left to the farthest right. So my farthest left is right here. Okay, and the x value that goes with it is that -5. Since it's on the graph, closed circle, I use a bracket for that -5, and my farthest right is right here, and that matches the number 4, and then I put a bracket. So this graph goes from the farthest left -5 x value and the farthest right, which is 4. Now let's switch our brain around. Make a click in your brain, and now you're thinking lowest to highest. So my lowest value is right here, okay, where that same farthest right x value is, but now we want the y value of that coordinate pair. That y value of that coordinate pair is right here now at -2. And my highest value is this one as well, but now we're looking at the y value of 3. Okay, so lowest to highest is my range, farthest left to farthest right is my domain. Okay, so this is an example of domain and range and the notation we use for domain and range. Okay, this is the most complicated concept here. So again, like I said, please ask for help if you need it. Please be listening with your audio and please ask for help if you need it. It'll really help you with your practice. We also need to determine whether continuous relations can be functions. So we're going to use that vertical line test again like we did in the previous lesson. So let's redo that definition. So if you draw a vertical line, that line should never go through a point. And I'm going to say go through the graph instead of point more than once. So in these examples, I'm going to draw vertical lines through the graph. And on this one, it touches here and here, so that's a no. For the second one, if I draw vertical lines anywhere, it only touches one time wherever I draw it, so that's a yes. For this next example is a little different, but we only can draw a vertical line through this whole thing. And it touches all the points. Every single thing you draw that line through touches all those points, so that is a no. Next example, we draw a vertical line anywhere. It only touches once, that's a yes. This next example, when I draw a vertical line, it's going to touch at 2 places, here and here, so that's a no. This next one is a little trickier. It's a smaller line that you've got to draw, but it touches 1 place, 2 place, and 3 places. It touches here, here, and here, so that's also a no. For the next one, anywhere I draw a line, it only touches once, so that's a yes. And finally, this circle, all circles are going to be no, because when you draw a line, it's always going to touch in 2 places. So that's a no. So that's the vertical line test, and that's how we test with continuous functions. It's very similar to discrete functions. So we're going to do a lot of examples of this because there's a lot of different situations with domain and range and whether something's a function or not. So if I look at example A, notice that it's continuous. Even though it's got these 4 dots, that is a continuous function, not discrete, because those dots are connected. So remembering that domain is left to right, and range is bottom to top. Keep repeating that to yourself to memorize it. So my domain, I'm actually going to use purple for domain. So purple, the purple color I use is domain. So my farthest left is right here, and that x value is going to be 1, 2, 3, 4, 5, 6. So my domain with a bracket is -6 because it's not an arrow, not an open circle. And my farthest right is right here, and that is at the x value 3. Okay, switch gears now, make a click in your brain, and now we're going the most bottom, which is right here, and that's going to be at 1, 2, 3, 4, 5, 6. So -6 because that's a negative going down. And then my highest value is right here, and that's going to be at the y value -1 with a bracket because it's a closed circle, not infinity. Is this a function? Yes, if I draw a vertical line anywhere, it only touches once, so that is a function. This next example, farthest left is right here, and that value is 1, 2, 3, 4, 5, 6, 7. Closed circle, so it's going to be a bracket. And notice that this open circle here, that's going to be a parentheses with whatever x value it is. If I count over to the right, 1, 2, 3, 4, 5, I get a value of 5 for my farthest right point. Switch gears. The lowest point is this one right here, the same one as the farthest left. And that's going to be, now we're looking at the y value. So negative 1, 2, 3, 4, closed circle, so a bracket. And then my farthest right is right here, and that y value is 1. But we're going to use a parentheses because it is a open circle, just like the 5. Is this a function? Yes, because I'm going to draw a line through it. And it's going to only touch one place. Example C, my farthest left is here. That is an open circle at 1, 2, 3, so negative, and it's negative 1, 2, 3 because it's going left. Remembering that left is negative, down is negative, up is positive, and right is positive. So that's going to be at negative 3, parentheses, it's an open circle. My farthest right is right here at 1, 2, 3, 4, open circle, so it's a parenthesis. My range is lowest to bottom to top, so here's the bottom. That is always a tricky point because it's at the origin. The origin is always the coordinate pair 0, 0. So my range, my lowest range value is 0. That is what that y value is for that coordinate pair. My highest point are both of these. Both of those are my highest point, but they happen to be the same y value here and here, which is 1, 2, 3, 4, 5. Okay, and that is a parentheses because it's an open circle. So that's how open circles work and closed circles work. Remembering domain is left to right, range is bottom to top. This is a function because it only touches the graph one time wherever I draw a vertical line. Now let's look at some examples that have arrows, remembering that we're going to use infinity for these. So my domain, farthest left, is here. Farthest right is here and here. So the farthest left is 0 because that's at the origin and it's going to have a bracket. My farthest right are these two arrows, so I know it's going to be infinity, and because it's going to the right, which is positive, that's going to be a positive infinity. And it's going to have a parentheses because parentheses is always infinity. My range is lowest to highest. My lowest is right here, and that's negative because it's down, so that's going to be a negative infinity. You've got to put a negative in front. My range is right here, and that's also an arrow. So it's going to be positive infinity. It goes down forever and it goes up forever. So negative infinity to infinity is my range bottom to top. Is this a function? When I draw a line here, it touches here and here. So that's not a function, no. Okay, we're almost there. The last two examples. So let's look at example E. My domain now, if I go to the farthest left, that's right here, and farthest right is right here. Those are arrows and they're going up forever, so that's positive infinity as my farthest left. That was just this one that I circled, farthest left. My farthest right, let me take a step back. Since this is going forever to the left, remembering that left is negative, I need to put a negative infinity here. You see, it's very easy to make a mistake. I make mistakes all the time. Don't be too hard on yourself. So it goes negative forever. On the right now, that goes right forever and ever, so that's positive infinity, so negative infinity to infinity is your domain. Your range, your lowest range value is here at the origin, and that's a bracket. So it's at 0, and it also has these arrows going up forever, so that's positive infinity. Is this a function? Yes, because wherever I draw a vertical line, it only touches one place, so that is a yes. And finally, my last example, I'm going to do my domain left to right. The farthest left point is this arrow. Since that's going left, that's negative infinity. And my farthest right is this point right here, and that is at the origin, so it's at 0, and we use a bracket because it's on the graph specifically, not going forever, not an open circle. My range is lowest to highest. My lowest point is the same as my farthest right point on domain. Sometimes that's confusing, and I've done a few examples like that, but sometimes the points are the same for domain and range, and that's okay. But remembering that range is your y, and remembering that domain is your x. I'll repeat that for you. So the range lowest value is 0 with a bracket. And my highest point is right here. That's an arrow. Remembering that going up is positive. So my range is going to be 0 to positive infinity with a parentheses. When I draw my line through, it only touches once. So yes, this is a function. I know this was a lot of examples. I also know how difficult domain and range is. So you know where I am. You know how to ask for help. Please do so. That's what I'm here for. Good luck.